Hello, everyone. I'm Bradley Barth, your webcast moderator and senior reporter at SC Media. Welcome to today's presentation, Using a Next-Gen Web Application Firewall to Effectively Protect APIs and Microservices, sponsored by ThreatX. APIs are often a strategic necessity for conducting business due to the agility, innovation, and automation they enable. But despite their benefits, they also expose security teams to a slew of new challenges, including scaling, that can't always be solved by long-standing security tools and strategies. One possible way to solve the scaling issue is to tightly couple the deployment of security with your app. But this demands a lot from your security strategy and your web application firewall. To address this issue, today's webinar session will look at 8 key elements of an API and its accompanying microservices-friendly WAF. And it will also review the common challenges faced by application security teams to protect APIs and microservices. Our speaker today is Kelly Brazil, VP of Sales Engineering at ThreatX. As a web application security expert, Kelly is dedicated to helping global customers enhance their web app protection strategy and reduce risk. Kelly has dedicated his career to understanding and enhancing enterprise security and has spent the last 20 years introducing emerging security technologies to customers worldwide and aiding in their implementation. He has broad industry experience and has held positions at top-tier networking vendors and service providers, including UUNet, Juniper Networks, and Palo Alto Networks. For those who are interested from this presentation about slides, slides will be made available upon request. And also, just a heads up that there will be a poll during this presentation. So please, we encourage you to participate and interact with that poll. And we would certainly also encourage you to take part in the Q&A session that will follow the formal presentation as well. And so with that, I'd like to hand off to Kelly. Kelly, thanks so much for joining us today.
Thank you, Bradley. Appreciate that. I'm really excited to be here and talk about this topic. The genesis of this came from a couple of blog postings that I wrote. And so if you want further information on what we go over today, it might be good to check those out. But I'm very passionate about this topic, so it'll be fun to go over some of these things here. So I'll just advance the slide. So our agenda today is going to talk about the rise of APIs and microservice architectures. So things have been, obviously changing in the past few years in the application and development space. So the way that we secure them is going to need to change. So we'll talk about changes in application architectures and then how traditional application security needs to change to keep in step. We'll talk about some new security approaches that can be done with next generation WAF as it pertains to securing new web applications and public and internal APIs. And then we'll do a demonstration showing how we can secure APIs using a next generation WAF. So it should be a lot of fun. So let's talk about the rise of APIs. Obviously, just from a subjective experience, you tend to see more and more APIs out there. Objectively, for organizations that track web APIs, we see a huge increase over the past few years. And so, it looks like, there's more than 20,000 APIs that are being tracked by programmable web today. And kind of the funny thing about that is that's just the tip of the iceberg. That's just the public APIs that are out there. You can almost imagine behind every web app or public API, there are probably several internal APIs and microservices that are supporting that public API and a web application. So definitely, it's a huge attack surface area that's expanding. In fact, so huge that by 2020, Mark O'Neill at Gartner says that API abuses will be the most frequent attack vector, resulting in data breaches. So definitely something that we have to keep an eye on and make sure that we're adapting to the new threat landscape. So applications have changed. DevOps is a big driver in the past few years, and so we see things like the focus on speed and agility of deploying applications has really changed things quite a lot. CI/CD pipelines, agile development practices are replacing the old school type of development practices, which means that you're starting to see applications being updated on weekly or even daily, sometimes even more often than that, cycles. So the traditional security approaches are having a tough time keeping up with these continuous small improvements that are being deployed on a constant basis. We're also seeing that that developers are not reinventing the wheel as much as they used to, right? So basically using a lot of open source code and libraries, which is a good thing because that can actually speed up development and reduce errors and things like that. But there have been examples of exposures in open source libraries as well, so that's definitely something that needs to be taken into consideration. And APIs are a big part of that as well. So instead of having monolithic applications, splitting those out into APIs has really sped up development and maintenance of applications. And modular construction. So again, microservices architectures are kind of taking over the monolithic aspect. And so what that means is you can have different parts of an application talking across different data centers, right? And using APIs for that inter-process communication. And this has also been very important for mobile platform support, right? So in the old days, we just had the web applications, but now we have to support mobile and other ways of interacting with the site. And so APIs are key there. And sometimes you just have APIs talking to each other, automated script and things like that that also use the APIs. So there's a lot more ways to interact with a web application these days, and APIs are a big part of that. So APIs are at the heart of this transformation. So if we think about public-facing APIs, we saw how those are increasing over time and becoming more and more important. Things like even as simple as Google Maps APIs, right? They can actually help you enhance your own applications. Back in the old days, right, you used to have to scrape the website and parse the HTML and all that. Obviously, with RESTful JSON APIs, that's much easier and much more mainstream these days. And then you also have internal APIs, or in the security space, we might call that east-west traffic. But these are microservices that are talking to each other, and this really facilitates faster development cycles and code reuse and things like that. So this is not going away. APIs are just going to grow exponentially here. And it also, again, APIs are important to support things like mobile and other type of delivery mechanisms to your application. So again, it's not going away anytime soon. In fact, it's going to be growing. So we'll jump in here and just talk about API technologies, and this is by no means comprehensive, but if you think about APIs, probably the most popular seems to be, and I could be wrong. This is just kind of my own educated perspective here. Is RESTful JSON API seem to be the head of the pack these days. In the past, I saw XML APIs, including SOAP instead of REST. So it seems RESTful APIs are just so easy to stand up these days. They're just everywhere. GraphQL is another type of API that's very JSON, uses JSON as well, is becoming more and more popular. But we also see that instead of just pure HTTP protocol being used for RESTful APIs and GraphQL, we also see some APIs that are kind of hidden or encapsulated within WebSockets as well. And that's interesting because a lot of web application firewalls don't even look inside of WebSockets for things like SQL injection and things like that. So that's also an interesting kind of attack surface area that's largely uncovered. But we'll talk about next generation WAF can actually handle that. And then of course you have your authentication, right? So a lot of APIs are doing custom authentication with their own bearer tokens and things like that. But JSON Web Tokens and OAuth are also very popular ways. So being able to have a security layer that kind of understands all these aspects of the application is really key. So if we think about traditional security, there are some gaps there. So traditional security would include a traditional WAF, right? So as we all know, WAFs are not new technology. They've been around for decades now. And they were designed for web front ends. And purely just one reason why they're deficient is because you typically will only deploy them at a certain choke point. And so there's, as we'll see, there's a lot of ways that can miss a lot of legitimate and exploit traffic. But the reason they're also deployed in those areas of the network is because it's not very easy to deploy them anywhere else. They're typically not cloud native architectures, and they're typically not geared towards APIs, but they have hundreds of thousands of signatures that are very web app focused. And the API gateways are another piece. So these can also aid in security from the aspect of authentication. They do a lot of kind of routing of traffic and load balancing and rate limiting and things like that. But these types of solutions are not looking deep into the layer 7 payload and looking for specific types of attacks or doing any type of behavior analysis and things like that a next generation WAF should be doing. So there are some gaps there. All right, so legacy WAF is failing. Before we get into this slide, let's run a poll because we've talked about some traditional security, and so we'll ask the question: does your company treat API security differently than traditional web security? I'm not sure. Eric, can we run the poll there, or should I hit the button? All right. Wow. Okay. So far, so it looks like we have a 50-50 split, and we'll continue to see how that poll runs. But so 50% out there say that you can use the traditional WAF technology, and the other 50% say that no, we need to do something different. So hopefully, I can convince you that we definitely need to do something different by the end of this talk here. And so one of the things that kind of relates to that is, legacy WAF kind of has a bad name for a lot of people, right? Because it's a very static rule and signature-based approach. And so as you add more and more applications, you have a larger attack surface area. It's really tough to kind of apply a WAF towards not only your web applications, but also the expanding number of APIs, both public and internal. And the other thing that's really tough is that we'll talk about microservice architectures, is that it's actually tough to integrate a WAF into a microservice architecture like, say, a Kubernetes cluster and things like that, right? They tend to be very appliance-based. So it's difficult to get an appliance and even a virtual appliance into a microservices Kubernetes cluster or something like that. And then, of course, there's the constant tuning, right? These applications are changing quite often. So that doesn't really lend itself to these kind of newer CI/CD pipelines and agile development cycles. So if we talk about the traditional security architecture, let's just focus in on even just the placement, right? So typically you have your users on the left-hand side, you have a WAF in the middle there, and then you have your web application that it's front-ending, and then you'll have microservices or databases and things like that behind the web app. And so the way things work today is that you have your users and they go through the WAF and they hit the front-end application. And this is a typical architecture that's out there. But we'll quickly see how this is not going to work in all situations. So if we go to the next slide here, you notice we talked about mobile activity on a website. We've also talked about other types of orchestration and automation against websites. And a lot of time, that traffic is actually bypassing a WAF. Just because of pure architectural reasons, or maybe just the WAF doesn't have the type of technology to support that type of communication. And so this is a big problem because not only are a lot of architectures built this way, but it's actually difficult to integrate a WAF, a traditional WAF, into these points where the API conversations are actually happening. And as we can see, this actually gets even worse as you add more and more internal APIs and start to scale out the application. There's more surface area that the traditional WAF is just really ignoring. So we need a better approach, and so we're going to talk about that in the next few minutes here. All right, so the requirements for microservices security are a little bit different than traditional applications. So number one, it's got to be tightly coupled to the application. The security needs to be tightly coupled to the application. So this kind of choke point design that we have, and I've even seen things like transit VPCs in AWS and things like that. That's an older school type of mentality, but it's really the best that we've had up until today. And architects and DevOps teams and all of them, they don't like having to do that because it really kind of corrupts your elegant cloud architecture, and now you have to do kind of unnatural acts and hairpin traffic and things like that. So what you really want to do in a microservices architecture is to tightly couple the security and the application together, and we'll get into more detail on that one. The security has to be lightweight and performant. So we're sort of used to in the security land of having very robust security appliances that have a lot of functionality in them, and they have a lot of speeds and feeds and things like that. But that is a little bit, that doesn't work so well in the microservices area. You really want very small footprint, very fast and nimble type of architectures, or even containers or pods, right, that can perform this type of security within the microservice architecture. So we'll talk about what that looks like. But kind of gone are the days of an appliance that does 1,000,001 things. You want these things to do one thing very well and very fast without using a lot of resources of your cluster. And you want to protect both the front end and the back end. So you want to be able to use the exact same type of approach, but just scale it however it needs to, right? Be able to scale for the front end apps, and then as your microservices, your internal APIs scale up, you want to be able to get in between that traffic as well to see what's going on very easily. And adapt to their changing applications. So again, you don't want a situation where you have to tune hundreds of thousands of rules every time the developers deploy new code, whether it's internal or external facing. So there has to be a level of automation built into the system that can adapt on the fly, even if the application changes, multiple times per day. And then finally, it's got to be cost effective. I've been in the security space a long time, and sometimes when you look at a cloud architecture that's proposed by a security company, it doesn't really match up with reality. A lot of times there are licensing modes that are used so that the more kind of containers or instances that you use, the higher the cost goes. And that doesn't really work in an elastic situation where you want to be able to scale your microservices and your web apps up and down, maybe based on certain times of the year or certain traffic loads. You don't want to be having unpredictable bills on your security layer. So we want to be cost effective and kind of build security into the fabric of the application. So let's talk about this a little bit, integrating application security into the fabric. So What we have here is just kind of a very simplified, diagram of a Kubernetes cluster, which is, it's sort of the de facto standard these days as far as orchestrating containers, and this is kind of a way that we're seeing, more and more organizations move as far as building microservices. So the point here is that you want to deploy your application security the exact same way that you deploy your application. You don't want to have a special, snowflake type of deployment for your security appliance or virtual appliance versus, all of your web apps and your database containers and all that are just basically, numbers and code and not basically individually configured. So it's a big difference than what we're used to in the security space. There's sort of a saying where you want to treat these as cattle and not pets. We're very used to treating a security appliance as a pet, and it'll have a name, and you log into it, and you configure it, and you tweak it, and you get to know that appliance very well. In the microservices world, containers and instances can go up and down at any time. You don't really want to get attached to any one container because it should be what we call ephemeral. It should be able to go up and down and not affect the rest of the cluster. So what that means is that all configuration and maintenance has to be centrally managed. So at the end of the day, you want to just have a very simple API key or something that you deploy on the security layer, just like you would with the other parts of your deployment, so that it can be ephemeral and you're not hard coding configuration in there. So in this diagram that we're looking at here, this is something that is called a sidecar pattern. And so basically what this means is that within Kubernetes, you have this concept of pods, which is kind of the smallest workload that you would have in a Kubernetes cluster that you can manage. And inside of the pods, you can have multiple containers. And so it just so happens that ThreatX sensors can be deployed as containers inside these pods. And if you deploy the ThreatX WAF sensor in the same pod as your web service, which might be a public-facing web app, or it might also be an internal or external API service, then you're basically tightly coupling the security and the application together. And this is very important because now the security layer is a lot different than in the older type of designs where you just have a single choke point. Now the security is actually integrated with the fabric of the application, and it also scales with the application. And that's really cool because it means that the DevOps team doesn't have to worry about whether they scaled up an application and now do they have enough bandwidth or CPU resources on the security side to be able to cover it. They just basically scale infinitely and together without any extra processing or orchestration. So it's a very nice design that a lot of organizations like to use for their microservices, is that sidecar pattern. There are other design options as well that are equally effective and just have different pros and cons to them. But to me, this is sort of the more interesting kind of forward-looking design that we haven't typically seen within the security side of the house so often. And this is nice too because it kind of helps you to be very DevOps friendly, right? So you're not trying to overlay a security layer that doesn't really match up with how the application works and is deployed. Everything is very seamless, and really the way you deploy is just code, right? You're just deploying code in a YAML configuration file the same way that the DevOps team or the developers would be deploying the rest of their application. So there's no difference between deploying the WAF and the web application. It's all the same. So I really love this design. So this really fits with kind of the CI/CD pipeline, right? Because now you can deploy just like the app, but on the other hand, there's the problem of tuning a WAF. And so one of the important things that the next generation WAF should be doing is constantly learning any changes to the app. And like we said, apps can change multiple times, per day these days. And so being able to understand any new form fields or pages and all of that in near real time, so that there isn't this huge tuning, maintenance, and burden as the app changes. So again, this is also a way to make yourself kind of DevOps friendly within the environment and adapt to cloud architectures. All right, and finally, API protection. So we've talked about the architectures a little bit for how we implement security into the microservice architecture, but what can we do at that point? What can we do that's more than just a traditional WAF or API gateway? And so I have listed here a few things that are typically what you want to do. Again, we have a blog post that kind of gets into more detail on this stuff, but blocking things like unauthenticated requests, targeting layer 7 DOS queries, like maybe most attackers or most users of the API are hitting queries and they take 3 milliseconds to respond, and then this particular user is hitting a query that takes 5 seconds to respond. So if you see that type of activity, then you're going to want to be able to target or rate limit that particular entity. Of course, you want to be able to look all the way down into the XML and JSON body of the API to look for things like code injection, including SQL injection and things like that. API mapping is another concern where sometimes there's documented features and undocumented features of an API, and so attackers might be trying to map the API and looking for those undocumented features that they probably shouldn't have access to. So that's something you want to be able to detect and block. Brute force attacks, of course, whether it could be a form of mapping, or it could even be credential stuffing, or just trying to crack a password, things like that. Those should always be looked at. And JSON and WebSockets, right? So again, APIs are not just HTTP protocol anymore. You also have WebSockets, which can encapsulate an API. So being able to decapsulate the WebSockets and look inside of that is also important for a lot of organizations. Okay, so what I'm going to do now is do a quick demonstration, just kind of showing some of those things. We talked about the microservices architecture, but now what I want to do is talk about some of those things that we can do with the actual security of the application. So what I'm going to do is I'm going to log in to our console here, our dashboard UI. And we're going to go ahead and just track a few API changes here. So we're logged into the UI, and now what I'm going to do is I have this little shell script called API Fun. So in our demo environment, we have an API, and what I'm going to do is just run a few of these types of attacks against the API, so you can kind of see how we track that within ThreatX. So first what I'll do is I'll just run a good API query, and you can see the command that I'm running here is just a curl command. This is the username that's being passed and the password. And then this is the API endpoint here. So we're just doing a query to shipments /1, and you can see that we're getting the actual response back just fine. And then I can actually see that within our UI here. So one of the interesting things about ThreatX is that we track entities. And so I can go here, and I just happen to know that my entity name, because I did this before, is named Jolly Jennings. And so I'm going to go ahead and click inside there. And so you can see that we're tracking this entity over time. This is me, and I've done 2 automated curl requests to the shipments 1. So that's nice. You can see that the tracking is happening there. You can see the user agent is curl, which totally makes sense. And I have a very low risk score of 15. My intensity is a little bit elevated because I'm doing this in an automated fashion, so we're also tracking that as well. So if I go back into here, so the first thing that I want to do is I'll run a map command, and I'll show you what this does. So I'm just going to run a map against it, and what I'm doing here is running a bunch of curl commands, and I'm just going to different endpoints, and I know these endpoints don't exist, So I'm expecting to see in the WAF that being detected as sort of like a mapping type of attack there. So you can see that all of these attacks or these mapping type of requests have been seen. And then you can see also the risk score was elevated there. So now I'm up at a 31 risk score. And so I can basically see that over here, I can see that I had 10 404s in 10 seconds. So basically, my attack state has gone up to a scanning type. So one of the things that we do at ThreatX is we map attacks against a kill chain. So this is sort of the attack state, and you can go all the way up to exploit here. We'll show that in a little bit. So again, tracking everything that I'm doing as this particular entity. And so the next thing that we'll do is more of a brute force type of attack against this API. So I'll just say BF for brute force. And here you see what I'm doing is I'm actually doing a bunch of curl commands, but I'm changing the username over and over again. So you can see, the username here, blah, blah, blah. The username here is root. And I keep getting this unauthenticated or user does not exist error back from the API. So I could be doing this very slowly or very quickly. And so let's see if that is reflected in the UI as well. Wow. So my risk score went way up. And by the way, I'm not in blocking mode right now. I'm doing this just as a tracking mode. Otherwise, you would have seen me be blocked there already because I'm already at a risk score of 100. And at 100, at 70 is basically where we'll start blocking. So anyhow, I can see here some of these different things. So if I look at this orders one here, I can see 5 401s in 10 seconds, and that increased the risk score there. And so again, this is all kind of an additive thing, and this is the whole point of a next-gen firewall that does behavior analysis, is that we're tracking this entity behavior over time. I'm going to try unauthenticated. So one of the things, like we mentioned before, is you might want to look at unauthenticated flows. So I'll just do that. And you can see here that I did this curl command, and I left out the -u part, right? So it's not sending any authentication. And I got this forbidden back from the API. And this should show up here as well. Actually, I can see here now I have an exploit, and so we'll look inside of there, and it says block unauthenticated requests. So this is a specific type of rule that you can build into your API protections. We're already at 100, but this had a risk score of 90. So even if I was very low risk, that would have really bumped up the risk score of my Jolly Jennings entity. And then finally, one more attack that I want to run to show you, which is something you should be protecting your APIs from, would be an injection attack. So I'm going to go ahead and run a SQL injection. And here what you see I did is it's our curl command again, sending the username, and then I'm sending this as a post request. And inside my data or my payload, I'm actually sending what looks like some kind of SQL injection type of code, and I'm sending that to the V1 users. And so you can see that I'm not in blocking mode, so this didn't get blocked, and the application actually did respond something here, right? So in this case, what I want to do is take a look and refresh here, and see again we have another exploit. And within here, I can see that we see some SQL injection. And of course, that's the parameter there. Now, I'll hover over the description. And this is another interesting thing is that, the reason I didn't have to specifically tune, this is because we're basically looking for these atomic type of tactics and procedures. So we're looking for things like a semicolon or a dash dash or the word union. And since we're correlating all of these behaviors to a particular entity, and also these are not block or allow but additive behavior rules, this works without giving you a lot of false positives. So at the end of the day, you see this Jolly Jennings entity with a high risk score. You come in the morning and you say, well, here's all the breadcrumbs of everything that that entity was doing. So you can be very confident that this should be an entity that should not be using your API, whether it's a public API or an internal API. So that's the quick demo there. And I'll go back to the slides. All right, so I hope you enjoyed that. So we kind of went over, the different ways you can design a microservices architecture and actually embed security inside of it, and also what types of things a WAF or security device should be looking for when protecting the API. So, modern applications are increasingly decentralized. They might be talking across data centers or even across clouds. So being able to be embedded into the application is very important. The APIs are pretty much open these days and poorly secured, right? So you don't typically find a WAF in front of public or even especially private APIs. So this is a sort of a new attack surface area, as we know, is going to get worse and worse over time. And the microservices bring that communication deeper, right? So instead of just being at the application edge or the data center edge, we need to kind of get deeper into the application via some type of microservice architecture, whether it's the security layer pattern or a sidecar pattern, things like that. And the security must grow and adapt in lockstep with the application. So being able to scale with the application is very important. So deploy security the exact same way that you deploy the application, whether it's a web app or an API. And also adapt, right? So as the application changes, not having to require a lot of tuning, but just automatically learn the application and adapt the behavior rules based on that information. All right. So again, like we mentioned, the slides are available on request, but what we want to do is invite you to a deeper dive. I gave a very high level demonstration today about what the ThreatX WAF can do and a look inside the UI, but we'll be performing a more in-depth demonstration next week that we'd love to have you join. And if you have questions and things like that, it's always a great time to kind of deep dive on those too. So we'd like to invite you to that as well. And with that, thank you very much, and I think we'll be ready for question and answer.
All right, that sounds great. This is reporter Bradley Barth from SE Media rejoining. Thanks so much, Kelly. Appreciate it. And yeah, let's go do some Q&A. So first question that I see here for you is, we have lots of APIs, and sometimes we don't even know about them. How do we protect APIs if we don't even know about them?
Yeah, and that's pretty typical with the traditional method of basically trying to get in front of these and basically not be in constant communication and lockstep with the DevOps team and the developers. The nice thing with a microservices architecture is that you basically are automatically embedded into the API deployment process. So you don't really have to worry about that anymore. So if you deploy just like the application does, you're basically just code that is added into the deployment description or code. And so you basically just get added automatically to any new APIs that get deployed in your organization or in your application. So by moving to a microservices architecture, it pretty much takes care of that problem for you.
All right, great. Next question. Instead of the sidecar approach, why wouldn't I just add my WAF to be integrated as part of the web server with an example here of Nginx? Yeah, so I'm sorry, go ahead. Feel free to take that question.
No, I think it is very important to be very tightly coupled to the application. And by doing a sidecar pattern, you kind of get the best of both worlds in the sense that you're very tightly coupled with the application, but the security team is still has a separate view and control over the security layer. Whereas if you get too tightly coupled in, say, with the Nginx or with the web application with code, then all of a sudden a lot of the control is taken away from the security team. And so, a lot of organizations don't like that approach because of that. And the other thing about that is that it's very technology specific. So then you have to worry about what versions of code you're running, what types of libraries you're running. And the other thing about that too is that, when you make updates to the behavior rules and things like that, you don't want to be taking down the web service like Nginx. And so by keeping them tightly coupled but separated, like they are in the sidecar pattern, any updates or things you do on the security layer don't affect the uptime of the web application service.
All right, great. Moving on to the next question here. Most of what you explained, as well as the demonstration, seem to pertain to public APIs. How does the product apply to inter-microservice APIs?
Good question. So, a lot of focus is on the public APIs because that's obviously the most exposed area. But it's sort of old school thinking to think that you can kind of ignore internal APIs or east-west traffic. And so just by way of using the sidecar pattern, you're actually seeing internal to internal traffic that way. So you're automatically covered with the sidecar pattern. And the nice thing about that is, we can get deeper into the microservices architectures, but there's even things called service mesh. And so the sidecar pattern even works nicely with the service mesh, which gives you other kind of telemetry about that inter-process communication as well, and also has some nice features as well as doing automatic encryption of that. So by placing the WAF sensor container immediately after the service mesh allows you to kind of get all of these benefits. So it is important to see the internal traffic because if there is some type of a vulnerability and somebody gets in some way or another inside of the cluster, you don't want them to have free reign over those very sensitive communications. And so by having visibility and even enforcement inside there allows you to mitigate that very quickly if it does happen.
All right, great. Next question. Given that we are looking to support new architectures and DevOps, how integrated or independent should security be in relation to the DevOps process?
Yeah, I mean, they could be very complementary. In a lot of organizations that I've seen today, they tend to be a little bit antagonistic, right? Because you kind of have different objectives, right? And the goal is to actually bring those two disciplines together, security and DevOps, not necessarily the same organization, but at least in a way that you're being DevOps friendly, like I mentioned before. So that can be included in just the way that the security is deployed on the application. So a way to be DevOps friendly is to say, instead of this appliance that we need to hairpin traffic through, or instead of using a VPC, a transit VPC that's going to reroute traffic in crazy ways, we can actually just implement security into the fabric of the microservice. And that's something that would, makes the DevOps guys really happy right away, because now you're not kind of taking this beautiful architecture and making it inelegant with these kind of different traffic patterns. So just by doing simple things like that, you're already kind of integrating the two processes together. And I think also having security that is sensitive to the nature of applications is also a big thing. So being able to do that automatic learning of the applications instead of having to have a 2 to 4 week cycle of tuning a WAF, when you're talking about agile development cycles and deploying code daily, that 2 to 4 week tuning cycle just doesn't work with that. And so that's why traditionally people have not really advanced WAF inside of microservices. Whereas, today with next generation WAF technology, it is possible to be very DevOps friendly, both on the architecture side and also on the rollout of the application and the tuning of the application.
Great. All right. Let's keep those questions coming in. Next question for you is, if East-West APIs aren't exposed to the outside world, do I really need to worry about them?
You know, that's kind of an approach that we've had in security for a long time, but over the past few years, the thinking's kind of changed on that, where it's not enough to have a hard, crusty outside and a gooey, delicious middle. Now, basically, security, the general thinking is you want security in depth, and that includes securing even that east-west traffic, and at least have visibility into it, right? So at the very least, have some type of telemetry that shows you what's going on there, even if it's not blocking. Of course, having enforcement and blocking is the best case, but at least taking a baby step to having visibility internally is very important, because nothing is perfect, and if an attacker does make his or her way into the inside of the network, then they basically have free reign if you don't have any controls or visibility in place.
Great. Okay, next question. Can you coexist with my existing WAF? Is there a way to migrate from my current web application firewall solution without interruption in protection?
Yeah, I mean, absolutely. One of the things, there's several ways to deploy the WAF, and by default, it goes into a visibility mode, first of all. So there's ways to deploy the WAF just behind the existing WAF, so you can kind of see what the existing WAF is doing and some of the stuff that the existing WAF is missing. And there's also, sniffer mode deployments as well, so you're sort of out of band, so you can kind of do the exact same thing. So there's a lot of different ways to deploy a next-gen WAF so that it's not affecting your existing security infrastructure.
All right, next question. Can you share a little bit more about your overall threat ID and protection model?
Yeah, so we basically use a kill chain model. And so our threat model is a little bit different than a traditional WAF, where a traditional WAF is looking at every single request in isolation. And so what we're doing is we're adding context to that. So instead of looking at every request in isolation, we're correlating all of these to an entity. And instead of having very specific CVE, or exploit-oriented signatures, we're using more of tactics and procedures. And so the idea is that we build a risk model for an entity, and an entity could be one or more IP addresses, right? It could be hopping around IP addresses, it could be a botnet. And so we build this risk profile for an entity that we've fingerprinted. And so the nice thing about that is that you can get slow and low attacks, right? So that entity will keep building risk as it does some of these low-level reconnaissance and scanning type of things over time. We build that risk model over 90 days, and then we start looking for things like kill chain escalation. So maybe they go from, as we saw in the demo, we go from a application mapping or scanning approach to starting to play around with injection attacks and things like that. So that automatically is seen as a kill chain escalation and rapidly increases the risk score for the entity. So it's a big difference. Allows a lot higher fidelity of figuring out what is an actual threat versus a false positive. And it also allows you to not have to do so much tuning, because now you're focusing really on the attacker and the attacker's behaviors instead of having to know every single exploit that's out in the wild. And that also allows you to basically cover 0 days as well, because now you're not looking for discrete attacks, but you're looking for behaviors that are indicative of those attacks.
All right, great. Thanks, Kelly. Well, I think with that, we've just about run out of time. And so I'm going to officially conclude today's session. As a reminder, this webcast will be available on demand beginning tomorrow on the SC Media website under the Events tab. And again, for those who are interested, slides from this presentation will be made available upon request. Once more, I'd like to thank my guest, Kelly Brazil, for joining us today. And, of course, thanks to everyone else for tuning in. For SC Media, this has been Bradley Barth. Until next time, have a safe day online.